On behalf of our international sponsor, Canada, this week, we want to thank them. I hope you've had an opportunity to visit the Canadian AI Startup Pavilion. And if you are a startup, an enterprise, or a systems integrator, or any part of the AI ecosystem, I urge you to read the special report that AI Trends did earlier this year, and keep abreast of our updates from AI Trends as we continue to report on advances and a wide range of solutions and partnership opportunities that are available by Canada. But we have Inmar Giovanni, who is going to talk about that here this morning. So Inmar is a PhD, Senior Engineering Manager at Uber. And she's located in Toronto, where she leads a team whose mission is to bring from research into production cutting-edge AI for self-driving cars. Inmar received her PhD in computer science from the University of Toronto, specializing in machine learning, and was a visiting scholar at the University of Cambridge. Previously, she worked at Microsoft Research, Intel, and various Toronto startups in roles ranging from research scientist to VP of data, applying AI to various problem domains in robotics. And Inmar is an inventor of several patents and has authored numerous top-tier academic publications in the area of machine learning, computer vision, and computational biology. Please welcome Inmar Giovanni.
All right. Okay, good morning. Let's get started. My name is Inmar. I'm a senior engineering manager at Uber ATG. That's the self-driving division of Uber. And I'm here from Toronto, Canada today. And I just wanted to mention that we Canadians are pretty similar to Americans in many ways, but not quite. So for example, this is how we think the word center should be spelled. So Canada is an important and very unique player in the history of AI and in what's happening right now. I'm very excited and honored to be here today to share my personal story as well as that of Canada. And I hope that by the end you would also appreciate the contribution of Canada to AI and how exciting it is to be operating in Canada right now. So I've lived in Toronto for the past 15 years. I moved there to pursue a PhD in machine learning. And I chose to remain there, became a Canadian citizen, and it's my permanent home. But actually, I flew here last night, not from Toronto, but from Montreal, where the largest conference for academic technical AI is taking place right now, the conference called NeurIPS. I first attended it about 12 years ago as a young PhD student, and there were about 600 participants. It was very small, slow-paced. You know, we talked about our research and what's happening and what's exciting for us, very academic in nature. Everyone knew each other. The cohort of people who were my peers, PhD students, nowadays are leading a lot of the academic positions in universities all over the world and in Canada, as well as industrial research labs in all of the small and big companies, as well as their own adventures and ventures. So to give you a perspective about how things have changed in this last decade, when NIPS opened up, so NIPS right now, NeurIPS, sorry, just changed the names. It's about 10,000 people in attendance in Montreal. The tickets sold out in less than 12 minutes. Okay, so this is how things are moving right now. And that's because AI made the transition from something that's very academic to something that's very applied, and that's very exciting for people like myself. So let's talk a little bit about the history of AI. It's a very popular buzzword, dinner table conversation and topic of controversy, but it's not new. It started a while back. The term was coined in 1956 by John McCarthy, who is one of the godfathers of AI. He also made the observation that it's kind of hard to define what exactly it is, and so he was quoted as saying, "As soon as it works, no one calls it AI anymore." I first stumbled upon it as an undergraduate student. I was studying computer science and computational biology. I wanted to become a neuroscientist. I thought studying the brain would be very exciting. And then I took this class. It was mandatory, Introduction to Machine Learning. I didn't really know what it was about, and it was love at first sight. It was a combination of linear algebra, calculus, probability and statistics on the mathematics side, as well as from the computer science side, the data structures, the algorithms, and so on. And it was really a beautiful way of combining all of these things to solve problems that were fundamentally hard and we haven't really been able to solve. And a lot has changed since then. So I decided I wasn't going to be a neuroscientist. I wanted to build brains rather than understand the human brain. And so thus I moved to Toronto from Israel. And the University of Toronto was already one of the best places in the world to pursue research in machine learning. A lot of researchers from all over the world have been contributing to machine learning over the years, but Toronto and Canada in general were already standing out. And two of the biggest contributions or breakthroughs of the past few years can be attributed to research done in Canada. So I saw AI transform from this niche academic topic that perhaps 1,000 people worldwide really cared about and knew about, and everyone knew each other, to an area that now has hundreds of thousands of people taking online courses, engaging in working on it in industry, both on the technical and the business side. And we're all witnessing this explosion of AI worldwide. So what were these breakthroughs? One was the area known as deep learning that came out of Toronto and Montreal. And the other one was reinforcement learning out of University of Alberta in Edmonton. So I want to take a moment to clarify some of these buzzwords. So what's AI, for me at least? It's a branch of computer science that's concerned with the automation of intelligent behavior. So the goal of AI as a research area is to create software that imitates intelligent behavior. And the important thing about this definition is it doesn't tell you anything about how to go about doing it from a technical perspective. Within AI, and I have a little Venn diagram here, there is an area called machine learning. So machine learning is prescriptive about how to go about generating intelligent behavior, which is you're going to use data. Okay? So across machine learning, there is always the notion of using data and learning from examples. The most typical type of machine learning we see today is that where you give the algorithm a lot of different examples. Let's say that we wanted to provide an answer about something that's correct or incorrect. You give it a lot of examples with the correct or incorrect setting. And then hopefully after you turn some knobs and crunch some numbers, the algorithm, given a new example, will be able to perform that operation automatically. Within machine learning, there is an area called deep learning. So deep learning is a technology that's fundamentally inspired by the human brain, by the concept of neurons that are connected to each other and communicating with each other in order to make decisions. But it's a fairly abstracted view of the problem. It's not really like the human brain. So because deep learning is now powering most of what we call AI, people use all of these terms, AI, deep learning, machine learning, quite interchangeably. And then just a word about reinforcement learning. So this is, again, an area within machine learning that borrows the inspiration from human learning. So instead of giving it explicit examples and saying this is correct and this is incorrect, the algorithm gets rewards and punishments for doing things that are along the goal of what we want to achieve or not. And one of my favorite quotes is by Winston Churchill, and he said, "Success is the ability to go from failure to failure without loss of enthusiasm." And that is reinforcement learning in a nutshell. So we can attribute maybe the invention of that to Churchill. So now we're all hopefully on top of this terminology. The first technique that I mentioned, that of deep learning, so deep learning, deep neural networks. Neural networks have been around for a long time as well. They were first explored in the 60s and the 70s. They had a moment of glory in the 80s where people thought that they were going to be successful. That didn't really work out. The models were not strong enough. And so until about 2012, they were not really considered the right thing to pursue. Yet some researchers insisted on sticking to working on neural networks, on deep learning, and trying to push the technology forward. And in fact, in most academic circles, it was considered a bit of a joke to go after this. Of the less than handful research groups worldwide that still pursued deep learning, two of the three most important ones were in Canada. So the first one was the group led by Jeff Hinton, who has been studying them in the late 70s, became university professor at U of T since the 80s, and has been focusing on deep learning for his entire career. And Yoshua Bengio, who have been doing it since the late 80s, faculty of Montreal since the 90s. And then reinforcement learning was championed and led by Rich Sutton from the University of Alberta in Edmonton. So as you've probably all realized yourself over the last 5 years, and in particular, I would say 2 to 3 years, we're experiencing what people like to call exponential growth in AI. I'm a bit nitpicky about that because the exponent is actually a particular function that I don't think is the growth we have, but it's definitely a lot of growth and it's not linear. And this is absolutely due to the success of deep learning as a method in solving real-world problems. And this is the reason there are now dozens of algorithms running on your phone, running in the cloud, all powered by deep learning, all helping you every minute of every day, pretty much. And the applicability of AI for real-world problems is really what appealed to me in the field. When I was doing my PhD, it was relatively abstract and technical, without a lot of applications. But I did a couple of internships during my studies. I worked on search engines, I worked on the Kinect gaming system, and I really saw how you can take machine learning and AI and use them to improve the world, to improve people's experiences. And so when I graduated, I really wanted to work at this intersection between research and industry and help bring advanced research into production. So for me, someone living in Toronto, since I graduated about 7 years ago, it was a really incredible opportunity to see the ecosystem grow into something that's really bubbly and rich in a short amount of time. And 7 years ago, admittedly, there wasn't that much happening in AI in Toronto. So when I graduated and chose to stay in Toronto, I joined a company called Altera. Now it's part of Intel. I was working on algorithmic design as a research staff member on a particular type of chip called an FPGA. Back then, we weren't doing machine learning with it. Interestingly, now FPGA is a piece of hardware that can accelerate computation. It's come back a full circle, and a lot of folks in Intel are working on how to get deep learning models onto FPGAs. I did miss machine learning, and so pretty soon I moved on to my next adventure. I went to a company called Kobo. Kobo is kind of like the Canadian Kindle, so it's an e-reader. It also comes with an ecosystem of apps, a website where you can buy books. And so I worked first as a research scientist and later on leading groups of research engineers and software engineers. And we had a lot of different problems to focus on using AI for the purpose of making the reading experience better, making recommendation and search better, analyzing the text of the book through natural language processing in order to reason better about the user experience and the business in general. And so it was a very fertile ground for using many of these technologies. Later on, I worked again in a Canadian small startup, this time called Kindred. We were working on bringing robotic arms into warehouse automation systems. So the problem space there was to be able to pick and place different objects without really knowing what we were going to pick. And this was done through the combination of computer vision and machine learning. And so I think kind of looking, and then I moved to Uber ATG to self-driving. So reflecting on my career so far, it seems like I always like working with things that are tangible, that you can actually touch. And it's only that my toys keep getting bigger and bigger. So Uber. The Uber story in Canada, at least for self-driving, is very interesting. We have an R&D lab in Toronto, which is really a good example of a large US corporation deciding to set up shop in Toronto because of the unique talent for AI. The motivation for the lab was Professor Raquel Urtasun. She's a professor at the University of Toronto who's been focusing her research at the intersection of computer vision, deep learning, and self-driving. She was motivated by being able to have access to a lot of data, to a fleet of cars, to industry-level funding, and Uber was interested in having someone of her caliber go and join the organization and drive the development of innovative techniques in AI. And so about a year and a half ago, Raquel and her research team of about 7 students joined the company. Because Raquel wanted to stay in Toronto, they opened an office in Toronto. Now we're over 50 people, researchers and engineers, driving the new wave of technology for self-driving, publishing a lot of papers, but also taking them into production. So we recruit heavily from the University of Toronto and from Waterloo, and we have a very healthy influx of people coming from international destinations. My team is about 12 people right now, and they're from Iran, China, India, Brazil, Israel, Russia, and yes, even from the US. In the office is about 50 people. It's very international. We have very few people who were actually born in Canada. It's a lot of immigrants. And this is a very typical example. The fact that Canada is such a powerhouse for AI is well reflected in the amount of people choosing to be in Canada for their work, and also in the amount of companies, big companies that are setting offices, especially research labs for AI in Canada in just the last couple of years. So some examples, so we've mentioned Uber, Google AI with branches in Toronto and Montreal, DeepMind with branches in Edmonton and Montreal, Microsoft Research in Montreal, Samsung in Toronto, and just a couple of days ago, they announced that they're opening, well, a good colleague of mine is going to head the lab in Montreal, Facebook AI Research in Montreal, and NVIDIA in Toronto. So why is it that useful for companies to choose to do AI in Canada? There is this notion of being close to academic centers of excellence. There's a very interesting and exciting relationship between industry and academia in Canada. There was a realization a few years ago that this is an important connection, and there are good reasons to foster AI research and put resources into it. So thanks to the dedication of the Canadian provincial and federal government, as well as several industrial players, big research centers were formed or considerably grown to foster research and collaboration with industry around AI. So we have the Vector Institute in Toronto. This is led by Jeff Hinton as the co-founder, as well as several other rock stars from the AI community and rising stars that have joined the institute since. The Mila Institute in Montreal, headed by Joshua Bengio, and Amy in Alberta, headed by Rich Sutton. So let's take a quick look at these institutes. So for Toronto, we have in Vector, opened about a year and a half ago, 60 faculty members. These are professor-level individuals working on research in machine learning. About 150 students and postdocs. They have collaborations with over 40 companies. Mila in Montreal, they have been around under that name for quite a long time, but it's only in the recent couple of years that a lot of funding has gone into these institutions. Also, similar number of staff members and of students, as well as active interactions with the industry. And then Amy in Edmonton, a little bit less, but also a very strong setup of research center. So if you look at the sizes of machine learning groups in other academic institutes, this is very, very large. This is like a concentration of a lot of people who have world expertise in machine learning. It also means that folks who make the decision to either move from academia into industry or do it as a part-time, lead a research lab as part-time, they'd like to be close to, to their colleagues and stay in the area. So that drives a lot of the AI research labs in these cities and other cities in Canada. And overall, this gives an incredible incentive for anyone wanting to do advanced work in machine learning and AI to be close to one of these hotbeds. Other reasons for doing AI in Canada have to do with, in general, it being a very suitable place for doing businesses. So there are many measures put in place to make it favorable for foreign investment. Canada has a very stable and well-performing economy. There are a high level of education among its citizens, and it's generally known to be one of the best places in the world to live in. Setting up a business in Canada is very easy. In fact, it's considered the easiest place to start a business in the G20. It has very favorable tax rates. The combined federal provincial income tax rate of 26.8% in 2018 is one of the lowest in the G7. And in particular for R&D, there are a lot of tax advantages and generous subsidies. Canada has very easy immigration laws for skilled workers. So for someone in background in engineering or AI, it is exceptionally easy to move to Canada. In fact, there is regulation in the last, since 2017 that allows for a 2-week turnaround process to get a working permit. 2 weeks, 10 business days. And this leads to an influx of highly skilled individuals from all over the world and a very diverse workforce. And we know diversity is important. I think there was a discussion about it in the previous event here on stage. And I want to highlight one area of excellence of diversity that I am particularly proud of and care about, which is female leadership in AI. So I talked about Raquel, my boss, in our office at Uber R&D Canada. There is myself as the engineering manager, Raquel is the head of the lab, and our technical project manager is a female. So it's an all-female leadership office. In addition, and we're all immigrants. In addition, we have Doina Prikop leading the DeepMind office in Montreal, Sanya Fiedler leading NVIDIA in Toronto, Joel Pinot leading FAIR, the Facebook lab in Montreal, Futini Agrafiotti leading Borealis AI, which is the AI research branch of RBC, the largest bank in Canada, out of Toronto. Shelby Austin leading Omnia, which is Deloitte's AI initiative. So a lot of very strong female leaders in the area. Many of them immigrated to Canada and made it their home. So Canada is also a place that's very conducive to innovation, especially around technology. We have talked about how it's one of the large concentration of world experts in AI. There is the top-down support, so from provincial and federal resources, there is a variety of programs set in place to facilitate and foster innovation, including a Pan-Canada initiative that's led by the Canadian Institute for Advanced Research, CIFAR. And then from the bottom up, these research institutes that I've talked about have many different programs to help foster relationships with the industry, from classes for executives to teach them about AI, through helping organizations with setting up their AI strategy and how to onboard AI into the organization, collaboration opportunities for different projects, and access to a lot of excellent graduating students and interns. And another reason why doing AI in Canada is a great choice has to do with the engineering side of things. So for anyone doing applied AI, taking AI into production, you know that it's not just about having experts in AI. You really need an army of software engineers helping take this into production, making it robust, making it scalable. So there is a lot of different institutes generating amazing engineering students. I want to call out the University of Waterloo. They have a really good program for co-ops where the students spend 4 months taking classes and then 4 months doing internships, and they do it year-round. And so by the time they graduate, they have about 1.5 years worth of industry experience across many different companies. They are excellent students. In the past, they used to mostly go down south, but this is changing right now. And a few reasons why this is changing is this ever-growing Canadian tech ecosystem. It's turning out to be exciting. Toronto and Canada is one of the fastest-growing tech centers in the world with the largest number of AI startups. It's also one of the top most active spaces in the world for VC right now. Visa regulation making considerably harder to move to the US or to stay there, and so people are choosing to move to Canada or stay in Canada. And then you have the stable political and economic climate, making it a good destination for people to settle down and choose to live in. The exchange rate and the cost of living are such that, that Toronto ranks really high on the quality of workers and very low on the cost of on labor costs. So this is all leading to a noticeable brain gain, and people are coming back, staying in Canada, and moving from all over the world. And I want to spend a little bit, just a couple more minutes on Toronto as a case study, and mostly because I live in Toronto and I know the community really well. But from talking to my colleagues, this is pretty standard in many other cities in Canada. So Toronto is the fourth tech talent, has the fourth tech talent rating in a recent CBRE research survey. According to the same study, it's also number one, the number one place in the world where tech workers are heading to. It boasts several accelerators and incubators that are world-renowned. So the Creative Destructive Lab has multiple AI-related programs taking companies from early stages. Their companies so far, in the 5 years they've existed, raised over $500 million and have a market cap of about $3.5 billion combined. There are programs like Next AI, which invites people from all over the world with AI expertise to come to Canada, as well as business people, and together they allow them a space to form companies. The DMZ, which is an incubator out of Ryerson University in Toronto, is known as the best in the world, the best incubator in the world. And then there is the Mars Incubator and the Mars Center for Innovation. This is actually where the Uber offices are located, downtown Toronto, near the university, right on the same floor as the Vector Institute. So this building is basically bursting with AI companies doing very interesting things across many different sectors and domains. After the Vector Institute was started about 1.5 years ago, more than 10 AI research labs set their businesses in Toronto. That includes Uber, NVIDIA, Google Brain, Borealis, Samsung, LG Electronics, Thomson Reuters, GM, Etsy, Deloitte, Intel GPU Engineering Lab, and most recently, about 2 weeks ago, Didi, Chinese self-driving, announced that they're opening a center in Toronto. So things are happening at an incredible rate in Toronto, and I think this is a reflection of a countrywide phenomena. So in summary, AI is definitely happening in Canada. We're making a global effect, and we're very proud to be a fundamental part of it. Toronto, Canada, increasingly interesting spaces, very diverse, very vibrant to be doing AI in and doing business in. And I think this is a trend that is only going to continue. So I thank you for listening. I hope you enjoyed the conference and the rest of your day. Thank you.